grade 10s and welcome to term 3. It's an exciting term because we start doing all of the fun bits and pieces in maths. In the first 6 months we covered equations and expressions and functions and trigonometry and Euclidean geometry, and now we get to do really interesting things like analytical geometry. Now at first, analytical geometry sounds quite scary, doesn't it? It's 2 big words that are difficult to spell, and everyone knows how terrible my spelling is by now. But analytical geometry only really needs 3 formulae. There's the gradient formula that you know from last year, so you're going to be fine with it. And you also know it from our functions section. So the gradient formula ties in to the straight line formula. Are we going to do parabolas in analytical geometry? No, we just do straight lines and finding the gradient of them. Now, we also work with the distance formula and the midpoint formula. Now, these 2 we're only going to cover next week. So today we're focusing on the analytical geometry of straight lines, like parallel lines and perpendicular lines and all of those things. So you'll be great. And we can use the gradient to determine whether lines are parallel or perpendicular, all sorts of things. Okay, we've got a selection of activities to do. So we're just going to look quickly at the notes and then we're going to move through. So we have some key concepts over here. Firstly, you know already that the gradient is the steepness or the slope of the line. If we have a negative gradient, the line is going to go down. Look, you're feeling negative about life, your mood is going down. But if the gradient is positive, then the line is going up, just like your smile when you feel positive about life. The y-intercept is the point at which a line cuts the y-axis. So that's your y-intercept. Let's just underline it in blue. And that's your y-intercept over there. Now, your x-intercept is the point at which the line cuts the x-axis. There's your x-axis. So there we go. Remember that the x is the one that goes across. Look how we draw the x as if it's going across. And the y is what goes up and down. Look at that. It's like the tail of the y. Okay, collinear points are points that are collinear. They lie on the same straight line. So if we've got a straight line and we need to prove that 3 points are collinear, we need to prove that they all lie on that straight line. Parallel lines which remain the same distance apart at any time and at any point. Parallel lines are lines. Let's just insert that quickly. Are lines which remain the same distance apart at any point. And lastly, perpendicular lines are lines which intersect at 90-degree angle. Okay, so let's go to our first equation, which is the gradient equation. Remember, you might have heard it as rise over run. I talk about it as being the difference in height over the difference in length, I suppose. But really, it's the change in the y value over the change in the x value. The equation of a straight line is y is equals to mx plus c, where m is the value of the gradient and c is the value of the y-intercept. To find the gradient, we use the formula, and let's just rewrite it. M is equals to the change in y. Yes, I used some physics there. Over the change in x. It's the lazy way to write it. We should write it y2 minus y1 over x2 minus x1. Next slide. So we're starting with our questions. Make a neat sketch graph of the following lines. How many lines do we have? 1, 2, 3, 4. Now take a look at those. Do you see similarities and differences? Can you see why I want you to do them? They're all different in different ways. Now I'm going to give you 3 minutes to attempt these on your own. It's best to have a set of axes that are 5 points across, so they go up to 5 and down to -5, and the same on the y-axis. But let's just focus on the question, and you've got 3 minutes starting now. Okay, grade 10s, how did it go? Shouldn't have been too bad. It should have been a lot of revision from last term. For example, that y is equals to 4. Maybe it would have thrown you in the beginning. But I'm sure you leaned over and looked at someone else's work and saw how they drew a straight line just at where y was equals to 4. And that's exactly what we need to do over here. So let's go through that first question, where y is equals to 4. Now usually when we're plotting a function, we would calculate what the y-intercept is and what the x-intercept is. And we would do that by making over here y is equal, not y is equals to 0. Whoa, that was a close one. To find the y-intercept, we make x equal to 0, and to find the x-intercept, we make y equal to 0. But will that work nicely with this one? Not really, because where is the x? And we can't very well say that 0 equals 4 because it really doesn't have the same value as 4. So this is one of those unique cases where y is going to equal 4 the whole way along the line. So if I label this Cartesian plane, where y equals 4, we're going to have a line going the whole way across. So I'm just marking out some points just to make it more accurate, and let's call up a line, and we'll do that line. Oh, it's come out as yellow. Let's pick it up, and we'll just move it up to 4, and there we go. Y is equals to 4. So even when x equals 3, y is equals to 4. So 3, 4. And when x equals negative 2, what is y equal to? 4. And when x is equals to negative infinity, what will y be equal to? If you said 4, you would be absolutely correct. The whole way along this line, y will equal 4. So that's pretty easy. If we had a line of x is equals to, let's make it negative 1, what would that look like? Well, the whole way along the line, and let's change to pink, x would have a value of negative 1. So we would have a line that went through like that. X is equals to negative 1. So not so bad. Okay, let's get ourselves a clean sheet. We've done y is equals to 4. Now let's do y is equals to 3x. Now once again, I like to plot things by looking at the y-intercept and plotting that, and looking at the x-intercept and then plotting that. To find the y-intercept, we make x equal to 0. So let's substitute that in. X is equals to 0, which means y is equals to 0. And oh dear. Not oh dear, but oh, this looks interesting. Our x-intercept, or our y-intercept, has a value of 0, 0. Now if we make y equal to 0 and substitute it in, 0 is equals to 3x, that means that x will equal 0 as well, meaning our x-intercept is also 0, 0. Now grade 10s, this can sometimes confuse you because you're looking at it and you're expecting two different coordinates, but you've got the same coordinate. What does that mean about our x-intercept and y-intercept? They're exactly the same point. So this line is going to go through the origin. Can you remember or deduce, is it going up or is it going down? Well, the gradient is a positive 3. So that means the line will be going up at a rate of 3 blocks for every 1 block it goes across. How do I know it's 1 block across? Well, if we rewrite the number 3, if we rewrite the number 3 as a fraction, 3 is going to be over 1. So that means for every 1 it goes across, it goes 3 up. So I can now plot that. And that particular method of plotting is called the gradient intercept method. The intercept is 0, 0, but the gradient tells us for every 1 it goes across, it goes 3 units up. So there it is over there. How many points do I need to plot a straight line? I actually only need 2. Let's see if we can change this color to something more appealing. Black is perfect. Okay, so let's draw that line. And now let's get it to the right position. And you'll see that I've cut the y-intercept at 0 and the x-intercept at 0, or the x-axis and y-axis at 0, 0. And my other point that I've used has been 1 and 3. Okay, so there's my line. How did I plot it? Using the intercept and gradient method. The next one, we're going to pull up a clean slide, and this is the more conventional question. In the formula y is equals to mx plus c, m is your gradient. So in this particular formula, where y is equals to negative 2x plus 4, negative 2 will be our gradient. Can you remember what the c value was? Well, the c value is the y-intercept. Now, if I wanted to prove that, I would start by making x equal to 0 and substitute it in. So therefore, y is equals to negative 2 times by 0 plus 4, which means y is equals to 4, giving us a coordinate of 0 and 4. Okay, my y-intercept or my x-intercept is where I make y equal to 0. So therefore 0 is equals to negative 2x plus 4, which means negative 4 is equals to negative 2x, and x is equals to 2, so that means our x-intercept is 2 and 0. This method of plotting a function is called the intercept method. And I'm going to plot 2 and 0 and 0 and 4. And then I'm going to put a straight line through it. Let's select that again. And we're going to just drag it through there. And I'm going to make it a little longer. And there we go. Now it's important that you do plot the points, 0 and 4, because that's what you get the marks for, and 2 and 0. Make sure that your x-axis and your y-axis are labeled and that you've got arrows on the end of your functions. Grade 10s, I know we haven't done that last plotting yet, but we will do it after you've had a bit of a breather, maybe a drink of water, had a little bit of a laugh, and then are ready to concentrate again. We'll see you just now. Okay, grade 10s, are you feeling good? That's good, because a good attitude is the key to doing well in this section. That's all it is. It just takes positiveness from you. Okay, if you're positive, your brain can think. And when your brain can think, you're going to retain knowledge, so you're going to keep it in your head. Now, analytical geometry questions are fortunately usually quite easy. They're exactly what they're laid out to be. In this case today, when we're looking at the straight line, they're going to be questions like find the equation of the lines, plot a particular line, find the equation of one line if this line is parallel to it, and stuff like that. So make sure that you read the questions properly and answer them carefully, because this is where you should get full marks in any exam. Okay, we need to plot that last graph. So let's do it. Now the last one was very different because it was rearranged funnily. That's a nice word, funnily. So I'm going to make y the subject of the formula. Are you ready for the corny joke? You may ask why we're going to make y the subject of the formula. And the reason why we're going to do that is because the formula is actually y is equals to mx plus c. So it's just, oh, why did I draw a 4? That makes no sense. So it's just about making us feel more happy. There's our happiness. Okay, so I'm rearranging everything to get this. What do you notice about that and that? They are the same. Do you know why they're the same? Because I made a mistake. Helen made a boo-boo. I should have multiplied everything by a negative. So that was positive, and that would give me y is equals to negative 2x minus 4. Phew! Aren't we glad we caught that? Yes, we are. Very excited. So, what is our gradient? Our gradient is negative 2, and our y-intercept is negative 4. And I'm going to start by plotting that. Remember that with these kinds of questions, most of your marks, if not all of your marks, are going to come from your drawing. So you need to make sure that all information is included on the graph. So there we go. There's our y-intercept. How do we find our x-intercept? Well, we make y equal to 0 and substitute it in. So it was like that. And let's take the x over, why not? And that means that x is equals to -2. So we're going to put that point over there. Of course, it has the coordinates of -2 and 0. And that means we can plot it using a ruler, please, people. This is a straight line. You need to use a ruler for a straight line. And let's do this. I'm just going to draw it through here. Nice and straight. And you see, it goes like that. Okay, remember that you do get marks or marks deducted for not labeling your axes. So you must have the labels and you must label your line as well. In this case, our line is y is equals to -2x minus 4. So it's important to write that there. Okay, grade 10s. So plotting the straight lines shouldn't have been too difficult. In fact, you should have flown through it and should have really enjoyed it. Should have made you feel clever. Can you do the opposite though? If I give you lines that have already been plotted, can you find the equation of them? Remember, when you're trying to find the equation of a line, you need two pieces of information to substitute into the formula. You need the gradient and you need the y-intercept. Y equals mx plus c. Y is equals to the gradient multiplied by x plus the value of the y-intercept. Let's take a look at the next question. Okay, find the equations of the lines in the sketch. How many lines do we have? We have got, well, let's just do these three over here. We've got FG, and we've got AC, and we've got AB. Okay, I'm going to give you 3 minutes to find the equations of those 3 lines. Enjoy it. Okay, grade 10s, you should have found that pretty easy. But let's see how you did. Remember, you're looking for the gradient and the y-intercept, and there are various ways or methods you can use to calculate either. Now in this case, we've got a beautiful graph with grids, so it's quite easy to see what the coordinates will be. Okay, so I'm going to label the coordinates because that will make it easier for me. This has an x value of 0 and a y value of 3. And this coordinate over here has a y value of 0 and an x value of 1, 2, 3, 4. So 4. So I'm going to start off with the line AC. Let's extend the page. So AC has two coordinates that I can work with. They're both intercepts. And they are 0 and 3 and 4 and 0. Now this is the y-intercept, so that means that C will automatically be equal to 3. But how do I work out the gradient? Remember, gradient is equals to y2 minus y1 over x2 minus x1, and you will have that formula on your formula sheet. So if we substitute these values in, let's call this point 1 and this point 2, then we've got our x value and our y value, x value and our y value. Our y2 value is the y value in the second point, so that's going to be 0. Our y1 value is the y value in the first point, which is 3. Okay, our x2 value is the x value in the second coordinate, which is 4. Oh, let's make that in blue just to keep continuity. Oh, it's nice. Okay, and our x1 value is the x value in the first coordinate, which is 0. So actually quite an easy calculation. It means that our gradient is going to be equal to negative 3 over 4. So that means our line has an equation of y is equals to negative 3 over 4 x plus 3. And if we look at the diagram, that makes a lot of sense because, and let's get away from or rub out all of the rubbish, we've got a y-intercept of 3, and for every 4 units it goes across, it's going 3 units down. So, what do you think? How did you do? You feeling good? You ready to do the next one? Now you'll notice that the next one is perpendicular to the one that we currently have. Did you pick that up? There's a 90-degree angle. But are we able to just assume that? And typically I would say no. But in this case, I would say that this is probably what we want to observe with this kind of exercise. If two lines are perpendicular to each other, in other words, they meet at 90 degrees, their gradients will be the negative inverse of each other. So that means if I have a gradient of 2 over 3, my perpendicular line will have a gradient of negative 3 over 2. So you see how the 2 and the 3 swap positions, and it went from a positive to a negative number. I like to think of it as exactly opposite in every single way. Okay, but let's prove that these two lines are perpendicular to each other by finding the equation of the other one. So I'm erasing all of the other rubbish, and we're now working with line AB. Now in AB, I have the coordinate 0, 0. So let's write that over here. And let's do this coordinate over here, which is going to be negative 2 and negative 3. Okay, how did I get that? I read it off the graph. So my y-intercept or my c value is going to be 0 because it cuts the y-axis at 0. But my gradient is going to be -3 minus 0 and -2 minus 0, which gives me an answer of 3/2. Is that perpendicular to this? Oh, I was wrong. No, this has a gradient of -3/4. So the perpendicular line to that would have a gradient of 4/3. Does this have a line, gradient of 4/3? No, it doesn't. So I assumed incorrectly. Let's go back up to our equation and substitute it all in. Y is equals to 3/2x plus 0. Do I need to write the 0? No, I don't. Okay, the last line, we have just enough time to do, was FG. Now for FG, it's going straight up and straight down, which means the whole way along, x has one consistent value. Over here, x's value is -4 and y's value is 1. Over here, x's value is -4 and y's value is -2. Over here, x's value is -4 and y's value is 3. 1, 2, 3. Sorry, not 4. Started writing 4 and it's not 4, it's 3. So the whole way along, x has a value of -4. And that means that's the equation of the line. Nice and easy, isn't it? So we examined the equation of 3 different lines, FG, AB, and AC. Not bad. Grade 10s, we're going to take another bit of a break. I want you to take deep breaths, walk around a bit, feel relaxed so that when we come back, you're ready to tackle some questions that have some words in. Don't be scared. You can do this. I'll see you just now. Grade 10s, does it feel a little like we've gone back in time? Like you're doing grade 9 work already, or you're doing it again? And that's basically what this is. This is why you're going to do so well in it. You really, really are. Because you know this. You really do. Now, in a short while, we're going to be doing some word problems. But the word problems, you'll see, are actually quite easier. Or easy. As long as you know what the words perpendicular and parallel mean, you're going to be great. You really are. Okay, but before we get to that, I'm going to put another graph up on screen. And I want you to find the equations of each of those lines. Now in this case, you're not given a grid, but you are given coordinates. So let's see how you do. The question says, find the equations of the lines in the sketch. So I'm going to scroll down. Once again, there are only 3 lines. We've got line AB that I want you to find. We've also got line CD, and we've got line EA or AE. Let's make it AE, alphabetical. I'm going to give you 3 minutes. Let's see how you do. Okay, grade 10s, how did you find that? Did you get a little stumped with line AB? I'm going to tell you why you might have got stumped over there. But first, let's find the equations of those other lines and see if there are any interesting relationships about them. Okay, now one of our favorite things to do is to have a line like AE. We're given the coordinate of A, but we don't know what the coordinate of E is. So how do we find what the gradient is? And the clue is over there. We don't need to write down that it goes through the point 0, 0 because it's obvious that it goes through there. That's why it's 0, 0. But if you forget to look out for that, then it's difficult to do these questions. So as soon as you see any line that goes through the origin, which is 0, 0, write down the coordinate and that will help you. So in line AE, we have got the coordinates 3 and 5, and we've got the coordinates 0 and 0, which means that our y-intercept is equals to 0. But what is our gradient? Well, our gradient is equals to the change in y, so that's 5 minus 0, over the change in x, which is 3 minus 0, which gives us a gradient of 5 over 3. So what is the equation of AE? It's going to be y is equals to 5 over 3 x plus 0, which is nothing. Okay, so grade 10s, I often get the question in class, do we change it to an improper fraction or leave it as an improper fraction and change it to a mixed fraction? My general feeling is that you should leave it as an improper fraction because you're probably going to have to work with it later on. And that means if you've changed it to a mixed fraction, meaning 1.5 or 2 3/4 or whatever it is, you're going to have to change it back to an improper fraction in order to work with it again. So it's almost like you've created more work for yourself. And fractions are our friends, so there's no reason to be scared of them. So leave your answer as the improper fraction and write it down. How did you do with line AE? I'm sure you did great. Let's go and look at the next one. So the next one I want to go over is line CD. So let's just get rid of those scribbles and we'll change color. C has a coordinate -1 and 0, and D has a coordinate 1 and -2. Now you'll notice that we don't know what the y-intercept is, so we're going to have to calculate that. Let's start off with finding out the gradient. So m is equals to the change in y, so 0 minus -2, over the change in x, which is -1 minus 1, which is 2 over -2. So what's the gradient of that line? It's going to be equal to -1. So now I have a formula for the line, which is y is equals to -x plus, I don't know. Let's find out what that is. And how can you find it? You can find it by substituting one of the points. So let's substitute the point D, 1 and -2, into it. So y is equals to -2 and x is equals to 1, and we solve for c, which means we have -2 plus 1 is equals to c, which is -1. And our equation for the line is therefore y is equals to -x minus 1. Isn't that great? And look, that must mean that it goes through the point -1. Okay, now what I should have said in the question was that AB is parallel to the x-axis. And that would have told you that this point over here goes through at 5. Why? Because it's not changing its distance from the x-axis at any point. So what is the equation of this line? Y is equals to 5. There we go. And that's AB, obviously. Okay, grade 10s, you feeling good? You ready to try some of those word problems? Let's take a look at the first one. Find the equation of the line parallel to y is equals to 2 with a y-intercept of 7. Now, because this one is easy to look at, we're going to do it together. I've got two lines. One of them is y is equals to 2x. So I know it's going to go up because of the positive gradient. Now the other one has a y-intercept of 7 and it is parallel. So there we go. And 7, or the parallel, indicates that it's going to have exactly the same gradient as the previous line. So that means my new equation is y is equals to 2x plus 7. What would be the line that is perpendicular to this line? Well, if this gradient is 2, it means that the perpendicular line would have a gradient of negative 1 over 2x, and it's still going through a point 7. So that's the perpendicular line. Okay, let's go to the next one, and I'm going to give you 1 minute to try this. Find the equation of the line perpendicular to y is equals to minus 4x plus 6 with a y-intercept of 3. Okay, take your minute. We'll see you just now. Okay, so how did the perpendicular line go? Remember, perpendicular lines have the exact opposite gradient to each other. So you'll remember from the previous example where the line had a gradient of 2, its perpendicular line was the complete opposite. So it was negative a half. And when you multiply 2 and negative half together, what answer do you get? Negative 1. Okay, are you ready to do this question together? So our starting line has the equation of y is equals to negative 4x plus 6. So the gradient of our new line is going to be the exact opposite. In other words, 1 over 4. How is that the exact opposite? Well, whatever we multiply negative 4 by needs to equal negative 1. Negative 4 is actually negative 4 over 1. So if we're going to flip it and multiply it by negative, there we go. And that gives us an answer of negative 1. So that's how we find the gradient of the new line. But we're also told it has a y-intercept of 3, so that means c is equals to 3. So the gradient of the new line is y is equals to 1 over 4x plus 3. Not bad. Okay, last question. We're going to do it very quickly. Find the equation of the line parallel to that line and passing through the point 5, 4. So let's rearrange it quickly. I'm going to start by isolating the y, 12 minus 6x, and now I'm going to get rid of that negative 3, so it becomes y is equals to 2x minus 4. Fancy mathematics right there. Now it says it's parallel, which means the gradient of our new line is equals to 2. So therefore we have y is equals to 2x plus c. But how do we find c? Well, we just need to substitute the point 5 and 4 and solve for c. And let's do that quickly. 4 is equals to 2 times 5 plus c, which means that 4 minus 10 is equals to c. c is equals to minus 6. And I'm sorry for rushing through this, but I really wanted you to see something that was just slightly more interesting. Do you see how I slipped a C into that? You must be wondering why. I know, I'm full of great jokes. Grade 10s, you're almost at the end of your grade 10 year, which means you're so close to grade 12. I look forward to seeing you again next week, where we'll be doing more analytical geometry. Goodbye.